Welcome back. In this section, we'll be talking about arithmetic sequences, which are a special group of sequences. They have a property that if you look at any two consecutive terms in the sequence and take their difference, you'll always have the same number. So if we're thinking more formally, we can say if you've got an arithmetic sequence, then there's some constant out there, where if you look at any two terms in the sequence that are consecutive, so term k and term k minus 1, if you take one minus the other, you will always get that constant value d, no matter which two pairs that you look at. So fifth term minus the fourth term will be d. 10th term minus the 9th term will also be d. That we have a common difference between any two pairs that we look at. So if we're thinking about an arithmetic sequence, we can define it recursively then, because number one, it's going to begin with whatever the first term happens to be. And since the difference between any two terms is always d, then to find the next term in the sequence, take the previous term and add on that common difference d. So when we're looking at this and trying to decide which sequences are arithmetic, then we just need to ask ourselves, does this go up or go down by a constant amount? So if I were to think about going from 3 to 7 using addition, or that would be going up by 4. From 7 to 11, that would be going up by 4. From 11 to 15, that would be going up by 4. And from 15 to 19, that would be going up by 4. So this is arithmetic. And we could say, well, we know that the first term is 3. And that if you want any term in the sequence, take the previous term and add that constant difference of, a common difference of 4 onto it. And so you can see that this is how we would generate the terms in our sequence. We had 3, adding 4 onto it gives you 7, adding 4 onto it gives you 11, adding 4 onto it gives you 15, and adding 4 onto it gives you 19. And then we could continue on to find further terms in the sequence if we wanted. Adding 4 onto 19 gives us 23. So we can say, oh, the sixth term in the sequence should be 23. Now again, when we're thinking about arithmetic sequences, these are things that go up or go down by addition. So something like this, if we're thinking, well, how does this work by addition? Well, you went up by 8, and then you went up by 40. These are not the same, so this is not arithmetic. So since these are not the same difference between pairs, then it's not an arithmetic sequence. One thing you might notice is there is a way to describe what's going on here, that if you were to think about it by multiplication, there is a pattern that you're going up by multiplying by 5 each time. And we are going to talk about those kinds of sequences in 13.3, sequences where the relationship is one instead of a constant addition. We have one where there's a constant amount being multiplied on. Okay, so the second one, B, this one is not arithmetic, so there is no common difference to identify. So that means let's move on to C. And for C, we have 1/2 going to negative 1/2, you would go down by subtracting 1. Negative 1/2 to negative 3/2, that's subtracting 1. Negative 3/2 to negative 5/2, that's subtracting 1. And same thing with the last one, that's subtracting 1. Of course, subtracting 1, you can think of that as being adding on negative 1. So there is a common difference. The common difference is negative 1. And I can say, well, C1 is 1/2. And to find any term in the sequence, take the previous term and subtract 1 from it. Okay, so next up, we have something where we've got a formula given. So here you have an being given a formula. So an is 5n minus 7, and we want to confirm that these are arithmetic sequences. So one way that I can do this without having to write out all the different terms in the sequence and just look at a bunch of numbers, I'm going to use our original definition that we gave for an arithmetic sequence back at the beginning, which was that if you look at AK times AK minus 1, so if you look at term K and term K minus 1, that there should be some constant that's a difference between the two of them. So that's what we need to look at here. What happens for my term here for AK and AK minus 1, and what happens when I take the difference. So AK, that would be 5 times K minus 7. AK minus 1, that would be 5 times K minus 1 minus 7, which, if I were to clean that up a little bit, that would give me 5K minus 12. And now, if I were to look at the difference between AK and AK minus 1, that would be 5K minus 7 minus 5K minus 12. And if I were to clean that up, the 5K minus the 5K will be gone. I'll have the negative 7 minus negative 12. That will be positive 5. And so we can see that, yeah, the difference between these two terms is a constant. It is 5. So it doesn't matter which term k we're looking at, the difference between these pairs will always be 5. So we can say, good, for this sequence, the first term in the sequence would be a1, which is negative 2, and that the common difference would be 5, that we're going up by 5 each time. So you can now say, okay, great, we have the sequence negative 2, and then the next number would be negative 2 plus 5, which is 3, and then the next number would be adding on 5 again, 3 plus 5, which is 8, and so on, and so on, and so on. I'm going to do the same thing for the second problem here for B. If I'm looking at CK, the term K, that would be negative 3 minus 2K. CK minus 1, that would be negative 3 minus 2 times K minus 1, which, again, I'm just going to clean this up a little bit. And now if I look at, just as I did before, CK minus 1, that would be negative 3 minus 2K minus negative 1 minus 2K. The negative 2K minus the negative 2K, those will be gone. And so I'll be left with minus 3 minus negative 1, which is negative 2. And again, that's a constant. That does not have a K involved in it, so it is something where the difference between the two terms is a constant, and the constant happens to be negative 2. So we can now say that our first term, C1, that would be negative 5, and that the common difference between our terms is negative 2. So we start at negative 5, and each time we go down by 2. So our sequence would be negative 5, negative 7, negative 9, and so on. Now, nicely enough, we do have a formula to give us, if we know the first term and if we know the common difference d, we can find a formula for the nth term in the sequence. We can find a general form for an. And so that formula is just your first term plus n minus 1 times your common difference d. So once you know your first term and your common difference, then everything is pretty straightforward for finding a formula. And then once you have a formula for an, you can find whatever term you'd like. So if we're looking at this sequence that we have here, you can see definitely it's arithmetic because you are going up by adding 3 each time. So we know that our first term, a1, that's 7, and our common difference, d, that's 3. So we can make our formula for an. An should be our first term plus n minus 1 times our difference, which, if I just clean that up, our common difference was 3. So I'll have 7 plus n minus 1 times 3, or 7 plus 3n minus 3, which cleans up to give me just 3n plus 4. There we go. So I have my formula. an is 3n plus 4, and now if I'm looking for the 100th term in the sequence, if I want a 100, I just have to put in 100 for n. And so the 100th term in the sequence, if we were to continue this sequence on, it would be ending up with number 304 as being the 100th term in the sequence. All right, this one, the numbers are a little bit harder, but again, it's not hard if you're working with a calculator. So with the one that we just did, it was pretty easy to see. From 7 to 10 you add 3, and from 10 to 13 you add 3, and from 13 to 16 you add 3. But the adding 3 you could also find just by subtracting. 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3. So even if you can't see the numbers immediately just by looking yourself, you can still figure out things using your calculator. And that's what I would do for the next problem, for B. So if you're looking at these numbers, it might not be obvious what the common difference is, but if you used your calculator and said, well, what's 11/12 minus 3/4? And then you'd use your calculator and find out, well, that actually turns out to be 1/6. And that 13/12 minus 11/12 is also 1/6. And that 5/4 minus 13/12 is also 1/6. So even though you might not be able to see just by looking at it what the common difference D is, with a little bit of work we can see that, oh yeah, each time we are going up by 1/6. So our common difference D is 1/6. And we know what our first term is. It's 3/4. So then Bn should be our first term plus n minus 1 times our common difference. And then I just have to clean things up a little bit here. So I'll have 3/4 plus 1/6 n minus 1/6, which is the same thing as 1/6 n plus 7/12. There we go. And then once I have that, I can go right ahead and find what the 100th term is in the sequence. That was the other part that we wanted to know. What is B100? So B100, that's 1/6 times 100 plus 7/12. And again, just using my fraction function on my calculator, I found that that was 69/4. All right, the last one that we're looking at here, C. So this one is, again, if we're looking at pairwise differences, each time you are going down by 5. We're subtracting 5, then subtracting 5, then subtracting 5. So our common difference is -5. So we've got our first term is 17. Our difference is -5. And so Cn, our formula, it is our first term plus n minus 1 times our common difference of -5. And just cleaning things up there, if you were to clean things up and simplify, you would get 22 minus 5n. And then the only thing left for you to do after that is just to find out your 100th term. And so next thing that we need to do is just put in 100 for n. And we'll have 22 minus 5 times 100, or 22 minus 500, which is -478. So the 100th term in the sequence should be -478. All right, last one. This one's a little bit trickier to do because this one we don't know the first term, and we can't find the common difference because the two numbers that we've been given are not consecutive. We're told the 9th term in the sequence and the 25th term in the sequence. So too bad for us, we can't easily find out A1 or D. But one thing we can do is just use what we know. We know that if we have a formula out there for this arithmetic sequence, that an should be first term plus n minus 1d. And so if you know that a9 is 19, then that means 19 should be a plus 9 minus 1, which is 8, times d. And same thing with the second fact that we know, a25 is 25. That means 25 should be a plus n minus 1, so 25 minus 1, or 24d. And so now at this point, you really just have two equations, two unknowns, and you can use these equations to solve for a and for d. I'm going to take these two equations and I'm going to first rewrite them as a equals. So the first one is a equals 19 minus 8d, and the other one is a equals 25 minus 24d. And so since a is equal to 19 minus 8d and it's also equal to 25 minus 24d, then 19 minus 8d should be equal to 25 minus 24d. And I can use this to solve for what d is. So bringing the d's all on one side gives me 16d, and moving the 19 to the other side gives me 6. So I can find that d is 16 over 6, which is the same thing as 3/8. And then once I know what d is, I can use either of these two equations to find out what a is. I'll use the first one, so I can find out that a should be 19 minus 8 times 3/8, which is 16. So now we know what d is, now we know what a is, so we can say that an is our first term a, which is 16, plus n minus 1 times d, which is 3/8. So there we go. The formula for an, and if I wanted to simplify this, I could, so might as well. So we would have 3/8 n, and then there would be 16 minus 3/8, which is 125 over 8. There we go. So we've got our formula for an, we know our first term is 16, and we know our common difference is 3/8.